ES modules in Node.js. Something, but not quite entirely unlike CommonJS. He had found a Nutrimatic machine, which had provided him with a plastic cup. The way it functioned was very interesting. When the drink button was pressed, it made an instant but highly detailed examination of the subject's taste buds, a spectroscopic analysis of the subject's metabolism, and then sent tiny experimental signals down the neural pathways to the taste centers of the subject brain to see what was likely to go down well. However, no one knew quite why it did this, because it invariably delivered a cup full of liquid that was almost, but not quite entirely unlike tea. So, apologies to the late Douglas Adams. ES modules are coming to Node.js. I know we've been hearing that for 3 years, maybe more. And I'll talk about that in the last part of the talk. Why is it taking so long? So this is CommonJS. CommonJS is the module system we all have come to love about Node. It's the one that we use require for. The first time I gave this talk, it was in Japan, in a Node conference in Japan. So I used the theme of tea, which is why it's called like this. So let's say we have a module called kettle, and it exports 3 things: handle, spout, and tea. So we just require it, and when we run it, it prints out something. ES modules, same thing. Look at that. Almost, but not quite entirely unlike ES module, CommonJS. This works today. You can try it out. You just do node -- experimental module, main.js, and boom, it works. You just import. And it's so similar. And what I want to talk about today is the similarities and differences between the two. And through those similarities and differences, we'll understand the architecture of ESM in Node.js, because the subtleties are interesting, really, really interesting. And through those subtleties, we'll understand why it's taking so long. So hi, I'm Gil. I'm old. I go back to the 80s. I used to write assembly code in DOS, if somebody remembers that. Somewhere around 2000, I found that the best way to write good code was to test it, to write code that tests it. And so testing code is my passion, which is why when I went to a job interview at Applitools, I was like, this is what I want to do, because Applitools writes testing tools for developers. Specifically, it's all about visual testing, which we don't care as much as back-end developers if we're doing Node. So hey, back-end, who cares about visuals? But as front-end developers, it's important not only to check that the button functions correctly, we want to check that the button looks okay. So that is what we do. So if you're serious about testing and visual testing, come talk to me after the talk. And that is the only thing I'm going to talk about Applitools. Okay, similarities and differences. First, let's talk about the most controversial thing, the file extension. And this is the biggest ouch here. On the right side, CJS, CommonJS. On the left side, ESM. First thing we can see is that in CJS, the file extension is the one we've come to know and love, JS. And on the left, ouch, MJS. Module.js. Why? First of all, we need to understand the rules of ES modules. With the first rule, a module is an ESM module. It's an ES module if and only if the extension is MJS. And a module is CJS if and only if the extension is JS. And a lot of people call them Michael Jackson scripts. That was before the documentary that's running at Netflix, so sorry. Only ESM modules are allowed to import and export. And only CJS modules are allowed to use require. So we have basically 2 branches, CJS and ESM, and they can't mix. We'll see that they can mix, but Basically, they can't mix. Why? Why did they choose a different extension? It's the most controversial thing about ESM in Node.js, and it makes sense. And the reason is this. It's not just... ESM is handled differently from CJS. For example, a CJS module is by default non-strict. If I want it to be in strict mode, I have to write the pragma use strict. Everybody knows what use strict means? It means, for example, that if I assign a variable that was not declared, in non-strict mode, it will become a global variable. In strict mode, I get thrown an exception. I think it's type error. This is one example of strict mode. I don't remember the others. As an ESM module, according to the standard, is by definition strict mode. You can't unstrict it. You don't need the use strict. So when reading a file, we need the interpreter, V8, needs to understand whether the file is a CJS module or an ESM module. It has to know that difference. And if the file just contains a console log hello world or whatever, no imports, no nothing, then it needs to know whether it's an ESM module or a CJS module. There were lots of proposals about how to keep the JS distinction. For example, let's parse the file. If there's an import or an export, then it's ESM. If there isn't, then it's CJS or all kinds of use ESM like pragmas. There were lots of proposals. None of them really work. And the Node people decided on MJS. And it kind of makes sense. Because, for example, an editor or a linter, when it sees an MJS file, it needs to know that it's by definition strict. So now an editor or a linter or any kind of static analysis tool knows that this file is an ESM file. So that's the first difference, MJS and JS. And we'll talk later about this because there are thinkings about this, how to change that. Named exports. On the right, yes, CJS, on the left, MJS. How do we do named exports in CJS? We do modules.exports.spout equals whatever, modules.exports.handle. You know it as exports.handle, exports.spout, but it's the same thing. In MJS, in ESM, it's all syntax. It's all part of the language standard, so you have a keyword, export. So you just export a variable, and boom, you've exported a named variable. How do I import it? I love destructuring. We were talking about that previously. So you just require returns module.exports. So if I want the handle, the spout, and the t, I just destructure them into the variables handle, spout, and t. In ESM, not a problem. It's part of the syntax. I do import and curly braces. Looks really, really similar. But this is, in ESM, this is part of the language. In CJS, it's something that basically Node gave. Default export. Let's start in this case with ESM. In ESM, you can export a variable or a function, and then it's a named export. But you can say export default and export a value. In this case, the value is a function. Export default scalding. And import, you just don't use the curly braces here. And that imports the default export. How do we do it in CJS? We just, instead of putting in objects inside module.exports, we just put whatever, a function and a number, whatever we want, and that's a default exports. In CJS, whatever is in module.exports is returned. So if in module.exports there's an object, so it's named exports. If there's another value, it's a default export. What if we want default and named exports? We have that in Node, in CJS, but it's really, really awkward. But in MJS, you just export default and export a variable or export a named function, and boom, you have default and named exports. And how do you import them? Without the curly braces and with the curly braces. Very easy. Makes sense. In CJS, it's awkward. I export a function, in this case, scalding. And now I need to export default, export a named export. This is really strange. What I do is I take that function, module.exports is now a function, and I add a property to it. We're in JavaScript land. We're not Java land or whatever. JavaScript land, a function is just an object. I can add properties to it. So I just add properties to it. And when importing, I get the function back. And now I want the named exports. I take the function and destructure the property from it. You can see that a lot of times, let's say there's a module called rimraf, which deletes a folder, a directory, and all its sub-directories and everything. So by default, rimraf is asynchronous. It accepts a callback. But if it's a function, that's the default. But if you do rimraf.sync, then it's a synchronous function, and it still works. So this is default plus named export. Binding. Oh, this is important. This is crazy important. And it seems like a really weird distinction, but it's at the heart of the difference between ESM and CJS. So it's subtle, but very important. Let's look at an example to understand binding. Let's look at the ESM first. You know what? Let's look at the CJS. I'm exporting spout, handle, and T. And I'm also exporting another named function called heatup. What heatup will do is it will change the T variable to scalding, from hot to scalding. That's what heatup does. Now let's use it. I import everything. I write handle spout, the handle and the spout, and then I heat up. What will be the value here? I know it, it's written. Yeah, but it will be hot T. Why isn't it scalding? Why hasn't it changed? Because what we're getting is not what we're importing here in T is not the variable T there. It's a copy of that. It's the value when I required that module. It's a copy of the value of T. ESM, when I heat up and change T to scalding, when I call it and I print T, it changes. Why? Because we're not importing an object and copying its properties. When we're importing, and remember this is a language feature, so they can do whatever we want. And they decided that when we're importing something, we're actually importing not the value of the variable. We're importing the variable itself. That's what is called binding. That variable that we're exporting, it's called a binding for some reason. I just call it a variable. So that is a huge distinction here. And we'll talk about that. Because in ESM, the whole process of importing is done in two phases. And you can read about it. Oh, no, you know what? Let's leave it for execution order because that brings the explanation better. So execution order, yeah, it is funny. Execution order. And from that, we'll get to the binding and explain the subtleties and the big difference between ESM and CJS. They look very similar, but they aren't. Okay, let's do the easy one. I'm doing two requires for kettle 1 and kettle 2. And between them, I'm console logging kettle 1 loaded and kettle 2 loaded. And what will be the output? If kettle 1 or kettle 2, just write kettle 1 or kettle 2. It'll be kettle 1 because I just required it. And then kettle 1 loaded. That's the console log. And then kettle 2, and then kettle 2 loaded. That's CJS. Because CJS, the require function, is synchronous. It is at that time, it's just a function. It's not a part of the language. At the time that I run the require code, it will load that module. What does loading a module mean? Just executing it. So this is synchronous. Now let's look at this. Import kettle, and then console log, and then import kettle 2, console log. Same thing. But we will get kettle 1, kettle 2, kettle 1 loaded, kettle 2 loaded. Why? 2 reasons. The import is not a statement. First of all, import can be only at the top level. You can't import something in a function. You can only top level. Import is a statement. It's a declaration. I want to import this. I don't care how, I want to import this. So you can think of it as import, import, console log, console log. That's one reason. But the more important reason is, yeah, in a way. Yeah, that's how I think about it. But it's more than that. It's much more than that. The ESM people, the standard, that's ES 2015, they defined very, very precisely the execution order of ESM. And it goes like this. First of all, I start with the top level module, the one that I'm running. If it has imports, I will import those modules. I will not run the modules. I will just read the modules and parse them. Why do I need to parse them? Because I need the imports and the exports. Now I have the exports of the module, I start doing the binding. I'm not running the module yet, but I'm doing the binding so that they will have a common variable that is common between the 2 modules. And then I see that the submodule also has imports, and I do this recursively. So now I've loaded, I can't do that with 2 hands. I've loaded the whole tree of modules, haven't executed one single line of JavaScript, but I've loaded this whole thing and parsed it. Now I can start executing. How do I execute? Top to bottom or bottom to top? It's okay. Bottom to top. Just like CJS. If you think about it, CJS goes bottom to top. It's what is called in-order traversal because you want the submodule to run before the module that imported runs. It makes total sense. If A imports B, I want B to run before A, okay? But what do we get from this execution order model? We get asynchronicity. We are allowed to load all those files and to parse them in multiple threads, asynchronously. It's okay, no problem. If you think about that, the number one problem, Node is very well known for its asynchronous module. It's really, really fast because it's asynchronous. But the first thing we do when running a Node program is we require how many modules? Hundreds, sometimes thousands. You know the joke about what's heavier than a black hole, right? Node modules folder. We sometimes load thousands of modules synchronously. That's crazy. ESM allows us, enables us to load things asynchronously. And I think, I'm not sure, that the ESM implementation in Node does exactly that, loads things asynchronously. The execution is synchronous. So bottom to top, synchronous. because JavaScript has to be synchronous in execution, but the loading and the parsing can be asynchronous. So that's crazy important. And it's the biggest difference between ESM and CJS. ESM can be asynchronous and should be asynchronous, and CJS is definitely a synchronous model. If you really want to understand this, Lynn Clark, the amazing Lynn Clark, has a cartoon kind of blog post. It's cartoonish, but it's really, really serious about this whole subject. Dynamic import. The joke here is that what's the difference between a homeless and a hipster? Yep. Dynamic import. As I said, import statements are only top level. I can't take an import and insert it in a function. So I can't do an if. If this, import this, else import that. I can't do that. Or I can't do lazy loading of modules. That's really, really bad. So there's this new thing called import as a function. So import can accept a string, a dynamic string, so I can build it from whatever, variables or whatever, and it returns the imports. But because ESM can be asynchronous, it returns a promise for the module. So I do an await. So I get the import, the promise, I do an await, get back the imports. So this is how I do dynamic imports in ESM. It has to be asynchronous. In CJS, it requires just a function. I want to do it top level, I'll do it top level. I want to do it in a function, I'll do it in a function, all good. And all synchronous. And that's a big, big, big problem. We'll talk about that later. Module directory name. We have come to know and love __ dir name. It's our best way to find files that are local to our module, resources that are local to our module that we want to load. We do path.join __ dir name, comma hello text, or as everybody does it, __ dir name plus / hello.text. And boom, we have a file name. No, not in ESM. In ESM, there's this thing called import.meta.url, which is not a file name. It's a URL pointing to that file, pointing to the file name. It's not a dir name, it's a file name. Why is it a URL and not a file name? Can anybody guess? No. Exactly. JavaScript is node agnostic and web agnostic, but it has to have a common denominator, and the common denominator is the web. It's a URL. So in the web, it will be HTTP URL or HTTPS. In Nodeland, it will be file : URL. So yeah, we have to have a URL, but this is pretty easy to turn into a regular file name using this thingy here. So remember, there is no __ dir name, but it's really easy to polyfill. So those are the differences between CJS and ESM, main differences. I think I've covered all of them or most of them. And theoretically, we can just move everything to MJS. But in reality, we will be living 5 to 10 years once Node lands ESM really without the -- experimental. We will be living 5 to 10 years in a world where both coexist. I'm optimistic with the 5 to 10 years. So we need to talk about interoperability between CJS and ESM. So let's talk. Otherwise, it will look like this thing. Yeah, ouch. Okay, remember the rules of ESM. A module is ESM if and only if the extension is MJS, and a module is CJS if and only if the extension is JS. And only ESM is allowed to use export-import, and only CJS is allowed to use require. And I can require only a CJS module. So how can an ESM module import a CJS? How can an MJS file import a JS? How can a JS file import a JS file, an MJS? It looks like these are two separate, inseparable worlds. Not inseparable, exactly the opposite, sorry. It seems like JS can't talk to MJS and vice versa. That's not very interoperable. But don't worry, there is a bridge over troubled waters, and we'll talk about that. Let's first talk about MJS importing JS. So we have an ESM module, and it wants to import CJS. It can, but only default import. So if I have kettle.js, this is a JS file, and it does a default export. It exports a value, not a name, not an object. Then I can import kettle from kettle, and it will work. So when I'm importing, it will first look for kettle.mjs. And if it's not there, it will look for kettle.js, and it will import default. Why? Why not allow named exports? Because if you will try importing a named import, it won't work. You'll get an error. Why? I asked that question, but I am on the NodeJS Working Group, so I'll have to answer that. There's a good reason. It concerns binding and the execution model of ESM. Remember, when does binding happen between two MJS modules? When does the variable binding between the import and the export happen? Before the module is run. Remember, there's a parse where the binding happens, and then there's the execution where we're executing everything with the binding. So I need to know what the bindings are, what the exports are, before running the module. Can I know in a CJS module what the exports are? Can I look, if I look at kettle.js, can I parse the code and understand what the exports are? No, I have to run the code. And that's a problem. You can't run the code because that is problematic in terms of ESM execution, but if you can't run the code, you can't have named exports. So the people decided, the NodeJS Module Working Group decided to have only default exports. And that's a huge, huge problem. Sorry? Yeah, so if you have a named export, this is an example. Kettle.js exports a named export, and you want to use that, you can either do import star as, or you can, you just do import kettle module from, and then do kettle module.kettle, because you're getting the whole object back, okay? What about the other way? CJS wanting to import an ESM module. That's less it will probably be less common. We'll probably be having new ESM modules importing old CJS modules, but not the inverse. But still, we will have that. So how do I do that? Can I use require in an MJS file? Sorry, can I require an ESM module? No, I can't. I'm not allowed. Anybody know why I can't require an ESM module? Require, is it synchronous or asynchronous? Synchronous. Loading an ESM module, is it an asynchronous or a synchronous process? Asynchronous. Hence, require cannot load an ESM module. This will fail. An import in a CJS module isn't allowed. But a wait import, a dynamic import, that is allowed. That's a function. in a way, it's not really a function. This is allowed in terms of the standard, of the JavaScript standard. So if you want to import from JS to MJS, you can do an await import. So yeah, you have a bridge over troubled waters. You can use default import and dynamic import to interoperate and to import from one to another. So we have interoperability. What about migration? You have this huge chunks of code, hundreds of thousands and millions of lines of code. How do I migrate from CJS to ESM? First of all, please don't do that now until it's out of -- experimental. I've heard of people doing it, not a good idea. Things will change. So please don't do this. But once you do this, these are probably going to be the rules. First of all, we have two migrations: as application developers writing an application, and as library developers writing a library. Let's start with the easy one, application developers. It's easy peasy. First of all, if you're using Babel in Node.js, please stop using it. If you're using TypeScript, I'm sorry, I don't know. Not a fan. Rename all J. I'm pretty sure they'll have a solution for that. I'm just joking. They're great. Rename all JS to MJS. Easy. Change all requires to imports. The syntax is really, really similar. So that's easy. If I'm importing a CJS module, remember it's a default import only. You have to accommodate that. But again, it's a technical thing. Nothing really major here. If you have a dynamic require inside a function, you have to change it to an await import. And that's a problem. Because if your function is synchronous and you have a require inside it and you change it to an await import, you have to change that function to be an async function, which means changing its caller to async, which means changing its caller to async. That's not a technical change. That is the only place in the migration where it's not a technical change. It's something you have to think about as a human being. Okay? You can't do a code mod to do this. But that's the only thing. Library developers. What we want as library developers, because we're living in a dual mode environment where we have both CJS and ESM, what we want is dual mode libraries, and I'll explain. Let's say Kettle is a library that I want to migrate from CJS to ESM. What I want is not only to migrate, I want it to be used from an ESM module like the top. I still want it to be useful as a CJS module. I don't want to abandon my CJS users. I want them to be both available as require and as import. That's called, in our lingo, dual mode libraries. How do I do that? Rules of migration. You can require a file. If you require a file, it will look for the JS file only. It won't look for an MJS. It will look only for JS. But if you import, it will look first for the MJS and then the JS file. And we'll use that to build a dual mode library. How? Let's say I have the Kettle package, and I write two files in it, index.mjs and index.js. Same code, one in ESM and the other in CJS. Same code, easy to write. I write it both. Now, if I import Kettle, it will get the top level MJS file. And if I require it, it will get the bottom level. So now I can write a dual mode library by having the same file written twice. Once as ESM and the other as CJS. And I'm done. But I have to write my code twice, once as ESM and once as CJS. That doesn't make sense. So what do? I write it once as ESM. And I use Babel to compile it to CJS. I compile all the MJS files to to the same location. So now I'll have MJS and JS one next to the other. And I need only two Babel plugins. Transform ESM to CJS. It transforms imports to require. And transform an await import into a require. So I write this. I Babelize everything using these two. I Babelize using these two plugins. I git ignore the JS files because they're a build product. They're not source code anymore. And now I can import with impunity code that was written once as ESM. Because when I import from Kettle, it will take index.mjs. And when I import from, and when I require Kettle, it will require kettle.js, which was transpiled from kettle.mjs. And there we go. And that is very important for me, at least. Future. As I said, I'm part of the NodeJS Modules Working Group. We meet bi-weekly. Is bi-weekly twice a week or every 2 weeks? So we meet every 2 weeks. We're about 40-plus members. It's a bit too much for my, these are my opinions, not the working groups. And definitely not my employer. We are working on the future of Node.js ES modules, and we're trying to figure out how to stop them being experimental. As I said, the opinions are mine only. Where are the problems if it's all this good? I believe that the main problem is developers, mostly front-end developers, but not only, already have code using ESM. Front-end developers mainly. Since React took over, everybody's using ESM in front-end as if they understand the standard. And they transpile it to CJS in Node. Or if they're not transpiling it to CJS, they're webpacking it using Webpack and bundling it in one big file. So they already have JS files that use ESM, and from their point of view, which makes sense, they already have ESM modules, but they can't use them with Node.js because of the MJS extension. Not only that, they're importing CJS with named exports. They're doing the curly braces, not allowed. And they're looking at us and saying, well, I don't care about this whole execution async thing. Just make it work. John David Dalton, which is a huge proponent of the Just Make It Works, in the Twitter he calls himself John Just Make It Work David Dalton, and he has a module called ESM that does the transpilation automatically and just makes it work in Node.js. They want their stuff to just work. And currently, it doesn't just work because of default exports and because of the JS-MJS extension. And both sides are right. There is no wrong here. Okay? The second thing that's holding modules is there are no require hooks. You know what require hooks are? Where you have dynamic transpiling. If you use Babel register, it dynamically transpile TypeScript to JavaScript or ES whatever to ES whatever. How does it do that? It hooks into the require function, and before the require does its thing, it transpiles, changes the source code, and then sends it along to require. Those are called require hooks. Mocking libraries also do require hooks, like sign-on and jest. APM, application programming, application performance monitoring, also does require hooks to hook into your functions. There are no such things. They're called loaders in the ESM world. We need to define what it is. Before that, it's a nice toy modules, ESM modules, but they're not really professional, production grade. And the last thing is a lot of members want web interoperability. Web already has ESM, but in a very, very primitive way. You can't just import Moment. If Moment is an ESM module in the Node sense, you can't just Why? Because browsers don't understand Node modules and the whole go up one level until you find the file thing. They just don't. They need a full path. But people want them to work together, and there are propositions in that area so that Node modules stuff will be working in the web. So these are the three main areas the Node Working Group is in. This one is the most, it's getting to splitting hairs problems, and it's basically two camps. We want to make it correct, which is the MJS camp, and we want to just make it work with existing code, which is the JDD camp, if you want. And everybody's working together in a nice and pleasant way, but it's really, really difficult. What can I say? Okay, well, this is the end. We talked about the similarities and differences of ESM and CJS. They look very similar, but when you get into binding and dynamic and execution order, you can see that they're very, very different, and that is what is making the whole thing difficult to interoperate. And we talk about interoperability, how ESM can import CJS and the other way around. We talked about migration, which is pretty straightforward, I have to admit, and a little bit about the future of NodeJS modules. Who knows when will they get out? So thank you very much.